Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over your Unit 4 homework. Question 1, is the north magnetic pole of the Earth north polarity or south polarity? That's south polarity. Question 2, what were early natural magnets known as? Lodestones. Question 3, south pole of one magnet is brought close to the south pole of another. Will the magnets repel or attract each other? Just like what we saw for charge, the law of electrostatic attraction, like charges repel, unlike charges attract. Similar circumstance, a law of magnetism, like poles repel, unlike poles attract. So in our example, two south poles interacting with each other would be a force of repulsion. Question 4, how can the polarity of an electromagnet be determined if the direction of current flow is known? The left-hand rule. Question 5, we're going to define some terms. Flux density, that's the strength of the magnetic field. Permeability is the ability to conduct magnetic lines of flux. Reluctance is the opposition to magnetic lines of flux. Saturation is the maximum flux that a material can handle or hold. Coercive force, the ability to retain magnetic flux. And lastly, residual magnetism, the flux that will remain. Question 6, a force of 1 ounce is equal to how many dynes? 27,800 dynes. Question 7, a Weber is defined as 100 million lines of magnetic flux. So 100 times 10 to the 6. And lastly, question 8, a coil contains 50 loops of wire and cuts through magnetic lines of flux at a rate of 20 Webers per second. How much voltage is going to be induced into the coil? So I've drawn the symbol for a coil and I've represented 50 loops on the coil. Magnetic flux is represented by the Greek letter phi, so 1 Weber per second is equal to 1 volt. So to calculate what the voltage induced would be, voltage is equal to the number of turns multiplied by the magnetic flux. So 50 turns times 20 Webers per second, this will create 20 volts, will give us an answer of 1,000 volts. Thank you.